In today's lesson, we're going to be looking at whether the sum or the product of rational numbers is rational or irrational. And then we're also going to look at if the sum or product of irrational numbers is irrational or rational. And what is the basis behind these things happening. So before we get started to look at the sum and the products of rational and irrational numbers, I want to mention one little thing, and you might want to make a note of it. A perfect square root number is rational. So our perfect square roots are like the square root of 4, which is 2, because 2 times 2 gives us 4. The square root of 9, which is 3, because 3 times 3 gives us 9. Square root of 16, which is 4. The square root of 25, which is 5. And these are all rational because 2, 3, 4, and 5 are rational numbers. The square root of the next one is 36 is 6. The square root of 49 is 7. Square root of 64 is 8. The square root of 81 is 9. The square root of 100 is 10. And these do keep going. But you need to know that any perfect square is a rational number. And then any other square root that's not perfect is always irrational, because it's going to have that never ending, never repeating decimal number. So you need to know those two things. So we're going to be looking at the sum and the product. Remember, sum means to add, product means to multiply. So if I'm adding two rational numbers, what will my answer be? Will it be rational or will it be an irrational number? So if I take, and this is just an example, you can take your calculator or something, but if I add 1.7 repeating, 1.7 is rational because it repeats, and I add 3/4 to it, which is a fraction, I get out the number 49 over 20. So 49 over 20, is that rational or irrational? We know that that is rational because it is a fraction. Anything that can be written as a fraction is rational. So anytime I add, no matter what, two rational numbers, I'm going to get out a rational number. Now what if I multiply two rationals? What will I get out? So over here, the square root of 49, is that rational? Yeah, it is, because it is 7. So then if I did 7 times 5 over 6, I get 35 over 6. And 35 over 6, we're looking at that answer. Is it rational or irrational? It is rational because it can be written as a fraction. So anytime I multiply two rational numbers, doesn't matter what they are, if both of those numbers are rational, my answer will be rational. Okay, what if I take and I'm going to sum a rational and then an irrational number? Okay, so if we look here, 4 square roots of 5 plus 3 square roots of 2. We haven't really gotten into how to add these yet, but we cannot add them. So is this a number I can write as a fraction? No. So it is irrational. So no matter what, if I'm adding one rational and one irrational, my answer is going to be irrational. Now what if I multiply a rational and an irrational number? Okay, so what if I multiply 2, which is rational, with pi, which is irrational? If I multiply 2 by pi, I get out this decimal 6.283185307 ... which means it never ends, it keeps going, and it never repeats. What type of number never ends and never repeats? That is a irrational number. So whenever I multiply a rational and an irrational, no matter what those two numbers are, if one's rational, one's irrational, my answer is going to be always irrational. And then the last set. What if we look and we sum two irrational numbers? The sum of two irrational numbers. So what if I add pi in the square root of 2? You could take your calculator and add these, and you get some number 4.555806 ... which means it never ends and it never repeats. So that is a irrational number. So whenever I'm adding two irrationals, no matter what they are, both of them are irrational, my answer is irrational. Now, what if I multiply two irrationals? Okay, such as the square root of 6 times the square root of 2. Well, I can multiply these. 6 times 2 gives me 12. The square root of 12, if I go look here, the square root of 12, was that in my list from over here, the square root of 12? No, square root of 12 is not a perfect square, which means if it's not a perfect square, it is irrational. Okay, now, but there's an opposite side to this one. What if I multiply the square root of 8 times the square root of 2? Well, 8 times 2 is square root of 16. If I look at that list, square root of 16 is a perfect square. It is 4. But the number 4 is rational. So when you're doing this type, when you're multiplying two irrationals, you've got to work the problem out to see what your answer is. Okay, so let's look at the steps here really quick. Steps. First thing you need to do when trying to figure out if I get a rational or an irrational answer, you need to simplify anything that can be simplified. So like if you have square roots, perfect squares, simplify them into whole numbers so you know what they are. Follow your order of operations, okay, PEMDAS, parentheses, exponents, multiplication, division from left to right, and then addition, subtraction from left to right. Then you need to identify whether the sum or the product is rational or irrational. Okay, so let's look at an example. The square root of 5 plus 8. Is the square root of 5 a perfect square? Is there a number I can multiply, a whole number I can multiply by itself and get out 5? No, it is not. I cannot add these two things because they're not like types of numbers. So my answer is still that, square root of 5 plus 8. Can I write that as a fraction? No, so my answer is irrational here. Again, I had an irrational. If you go back to your chart, this was irrational. And then 8 was rational. Whenever I add an irrational and a rational, I always get out a irrational. Okay, next one, square root of 16 times the square root of 81. Well, I know that the square root of 16 is 4, because 4 times 4 gives me 16. And I also know that the square root of 81 is 9. So I can simplify those, and 4 times 9 gives me 36. And 36 is a rational number. Okay. Find the sum or the product in example 2, then determine its classification. Okay. 4.1 times the square root of 49. Well, square root of 49 is a perfect square. 7 times 7 gives me 49, so I can multiply these. 4.1, let's classify these really quick. 4.1 is rational because the decimal ends, and 7 is rational. But if I were to multiply them, I can multiply them out, and I'm going to get 28.7. And 28.7 is a rational number because that decimal ends. And always a rational times a rational gives us out another rational. And you can always go and look at this chart here to help you through that. Okay, your assignment. You need to go through. You need to complete this daily practice, print it out, whatever you need, write on it. Show your work, and then you need to take a picture and upload it to Google Classroom. Also, for today's assignment, after you do this daily practice, there is a ticket out the door that goes with everything that we've done this week. It has just a few problems on it for you to go through and solve and submit. So you need to do that, and that is due by Sunday. So you need to get that all your assignments for this